Okay, welcome back to Orlando Math Learning Academy. In the previous video, I talked about the x-intercept and the y-intercept of linear equation. I also I did a review about the PEMDAS rule. So on this video, I want to give a lecture about one of the very important concepts in mathematics. And I'm sure that you already learned this in when you were in high school. You learned this in Algebra 1, excuse me. In Algebra 2, you were also introduced this in pre-algebra. This concept is very important concept. It's the most basic concept in mathematics. And when you go to a higher level, you also see this again in undergraduate level if you want to go to if you want to major in mathematics, or graduate level. Okay, so as you know, if you have two quantity and there's always a relationship between those two quantity, for example, if you the relationship between the velocity and the time, the faster you travel is the less amount of time you take on the road, right? So that is one of the relationship. Another relationship is if the area of the circle, or the volume of the circle, is dependent on the radius of the circle. So the volume of the sphere also dependent on the radius of the sphere. That is also one of the relationship I want to talk about. And you see, one quantity is always dependent on the other. If those relations follow a certain rule, and that rule I'm going to talk about in this lecture, or maybe in the next lecture, if it follow that certain rule, in mathematics we call it function. So let's go to the official definition of function. Okay, so this is I cover section 1.3, section 1.3 about function. Okay, and the first part I want to talk about is the definition of function. Okay, so mathematically, function is a relationship between two sets of elements. Function is a relationship between two sets of elements in a special way. So it must follow a special way. Okay, if you just take any relationship between two quantities, sometimes it cannot be a function, but it must follow a certain rule. I'm going to talk about that rule later. Okay, period. The first set, the element of the first set is called the input. It's called the input. Element of the second set is called output. So for each input we have an output. For each input, the function assigns an output, and the function can be notated as y equal fx. Y equal fx. Okay, so this is the notation, and y is the output right here. So if y is output and y equal fx, then of course fx, the whole thing here, fx is also output. However, the x, if I just talk about the x by itself, then the x is the input. Okay. And sometimes, most of the time, the x is called independent variable. Independent variable. Okay. And the y we call a dependent variable. It means that the y value is dependent on the x value. Whatever you put inside the function, we have the y, or we have the output correspondingly to that. Okay. And the function can be represented in many ways. Function can be represented in many ways. So I'm gonna talk. In this lecture, I just talk about three ways. The first way is table, then the graph, then the set. Okay. Example. I give you the table like this, and the input is the October. Okay, that's the input, and the output is the lowest temperature. So the lowest temperature is the y, and the date of October is the x value. Okay, and I have the x is 19, 20, 21, 22, 23, 24, and the output I have 52 degree, 65 degree. It means on the 20th day, the temperature on this day is 65 degree, 69 degree, is 72 degree, 67 degree, and 58 degree. So this is an example of the function using table. Okay. So this is a function. On the example 2, I also give you a table, but this table does not represent a function. I will tell you why. So on the x, on the input is the person weight in pound. In pounds, and the output is the person height in inches. Okay. If a person weighs 125 pounds his height is 64 inches. If the person weighs 200 pounds, his size is 72 inches, and so on. I have this. (200) is 68 inches, and 132 pounds, 66 inches. And I say that this is not a function because you see that we have two input which give you two we have the same input. We have the same input that give you different output. So if you look at a table and you look at the input and you see that the two input give you this, if you have the same input give you the same two input give you different output, then that is not a function. Okay. And there's another way to check if a function is a function or not, or if a table follow the function rule or not, or the graph follow the function rule or not. I'm going to talk about that later. But if you're using the table and you see the same input give you two different output, then that table does not represent a function. Okay. And the graph is easy. A function can be represented using the graph. It could be example 3. I might give you the example 3 like this. For example, I can graph the linear line here. So this linear line is a function, but I will go in detail why this graph is function in the next hour. Okay. And the set could represent a function can be represented using the set also. We using something called Venn diagram. For example, like this. This is the input and this is output. And in this set, I have element A, B, C, and the set over here I have element D, E, F. Okay. So an element A give you element D through the function. Element B give you element F through a function F, and the element C give you an element F also by the function F. So the function f x over here is a function. Okay. So the d obtained by fx, or we can say like this: the d can be obtained by fx. The e can be obtained by fx with the input b, and the f can be obtained by the input c through fx. Then fx is a function. Okay. Next, I want to talk about the domain and the range of the function. Okay, domain and range of the function. So we need to know what does it mean by domain and what does it mean by range. Domain is a set of all possible input of function and the range So the range is a set of all possible output of the function. And because the domain and the range are the sets, so we can write it using the set notation. Example, I might give you the domain, which is a set containing element 19, 20, 21, 22, 23, 24. This is domain. And the range, because the range is also the set, I can use the set notation. The range over here I have is containing the element 52, 65, 69, 72, 67, and 58. Okay. Or I can use interval notation. I can use interval notation also. Example 2. For example, the domain I have the interval is the interval from for example from -3 to 5, for example. So the domain is a set of all possible input of the function, or we can say that the domain containing is the set that contains all the x value that make the function define. What I mean by define, it means that as long as you put the input into the function, we can get a different output. Okay. Or sometime in the example 3 over here, sometimes they give you a function y equal, in this case y equal to 13 over x minus 2, and I want to find the domain of this function. And you see that this function over here has a numerator and denominator, and you already know that we cannot divide by a denominator by 0. It means under denominator cannot be 0. It means x minus 2 must be different from 0. And if I solve for x, so x could be different from 2. Okay, so for all the x value different from 2 will be the domain of this function. Okay, of the function here, y equal to fx equal 13 over x minus 2. Or if you write the domains in the interval notation form, I will have negative infinity, because everything except for 2, so it will be everything from the left of 2, negative infinity to 2, and not including 2, union with 2 and positive infinity. I mean everything on the right side of 2. Okay. On the number line I have 2 over here, and I don't include 2. Okay, so I draw a circle and I kind of cover everything to the right of 2. So this part and this part will be the domain of this function. Okay. Let's do another example. Example 4. Given the function fx or y equal fx equals square root of x plus 2 over x minus 1. Again, this function has the form of fraction. It has numerator and denominator. So we have to analyze one by one. We we are analyzing the numerator first, or denominator first, and denominator cannot be 0, so we put x minus 1 different from 0, x different from 1. On the top we have radical. As we already know, we cannot take square root of negative number. It means everything inside the radical, or we call it radicand, everything inside the radical must be greater than or equal to 0. And when we solve this, I have x greater than or equal to negative 2. So I have two different domains here. So I need to find the union of that. Okay, how are we going to find the union of these two domains? So first of all, I will graph the domain of the denominator. This is 1 here. Okay, different from 1, it means not including 1, and everything on the left side 1, and everything on the right side of 1. And I also graph the domain of the numerator on the number line, on different number line. Negative 2, so 1 over here, negative 2 on the left side of 1. And because it included 2, so I use the dot sign. Included negative 2, I mean I use the dot sign, and it's greater than negative 2, I mean on the right side of negative 2. Okay, and I will take the union part. I will take the union part of these two domains. So if we take the union part, it means we take everything, right? We will take everything from negative 2 to positive infinity, all right? So it means everything inside here. Okay. So the final domain will be from negative 2 to 1. Okay. Negative 2 to 1. Let me see. Okay, so I want to fix a little bit here. Not the union, but I want to take the intersection part of these two domains. Okay, so if I look at this number line here, the intersection, I mean the part is shared in common. It means this part, right? This part, because they share everything from negative 2 to 1, but not including 1. And union with, we take the intersection part, but when we write the answer we have to use union, because we have two different intervals. We have to use union from 1 to infinity. Okay, so remember, if you have two different kind of domain, if you have, most of the time you see that when you have a rational function or the function that in the fractional form, you have to find the domain of the top and the domain at the bottom. Then you have to find the intersection of those two domains, and when you write your final domain, the answer must be used with union notation. Okay, so remark. To find domain of function, So the first step we have to do, if the function is simple, we find all input that make function define. If the function is in fractional form, and we have to analyze the top and the bottom, as in this example 4 right here, we have to use intersection to get final domain. Okay, if you see something with radical, set the radical greater than or equal 0 to find domain. Okay. So the only two things you need to remember here. First of all, you need to find all the input that make the function define. The second thing is, if you have more than just one function, if you have more than just one part to find the domain for, you have to use intersection. Okay, and the answer you have to write using union because you have more than one interval. Okay, if you have more than one interval, you must use union to combine together. Okay. Okay. On the next example, I want to do a word problem. It's an example number 5. Okay, we haven't done any word problem so far, so let's try to do one word problem. In 2008, Tasha parents, let's write this together, okay? Bought her an $1,800 laptop, $1,800 laptop when she begins her home business after graduating from college, period. For the tax purpose, Tasha can deduct $360 per year for the next 5 years. Period. The depreciation of this laptop can be expressed as y equal 1800 minus 360x. and white represent the value in dollars of the laptop, and the X represent the number of years after 2008. Number of years after 2008. And the question is, I want to find domain and range. Okay. Alright, so how we can answer this? So she started her home business in 2008. And in this problem, they say Tesla can deduct $360 per year for the next 5 years. So she start from 2008, and for the next 5 years, even 2013, right? So the domain will go from, it goes from 0 to 5, and it should be included. I'm sorry, it should be included because initial year is 2008, so it's 2008. She already started, so it must be included. Okay, and the range will be the value in dollars of the laptop over the years. So the range over here, okay, the range over here, because you know that the value will be decreased. Okay, so initially the value is 1800. Okay, 1800. Okay, so over the next 5 years, the value will be 0. Right? And that makes sense, right? The range represents the amount of dollars of the laptop over the year. So for the first year, into which is 2008, the value of that laptop is still 1800. But for the next 5 years, okay, you plug 5 into this equation, you see that the value will be 0 because 1800 minus 1800 here. 5 times 360 is 1800. So 1800 minus 1800 will be 0. So the value also over the next in the last year of in the 5th year, that's why I mean will be 0. Okay. On the third part of this lecture, I want to show you how to evaluate a function numerically and algebraically. Okay. Evaluating function numerically and algebraically. So in order to evaluate a function numerically, we must be given a table. Okay, so first do it numerically. Given the table, for example, I have the table represent the function here. X here is the input, fx output, and I have 0, 4, 7, 24, and 50. So we have 5 input, and the output here is 9, correspondingly 12, -6, 58, and -19. And I already show you how to check if the table it represents a function by looking at the input, right? If we have the same input give you different output, then it cannot be the function, right? But luckily in this case it's a function because we have all different input and we have all different output here, so this is a function for sure. And I want to evaluate this function at input 7. We write it f of 7. Okay, at input 7 we have output of -6. It means f of 7 equal -6. Okay. The second method is by algebraically. And you must be given a function. So in this function, I give you fx equal 2x plus 8. And I want to evaluate this function at 8. Okay, evaluate at 8. It means that I want to plug 8 into the function. I replace the x value with 8. Okay, I replace the x here with 8. You see that? I throw away the x out and I put the 8 number in. 16 plus 8, 24. Okay. And the third method is by graphically. So I think I'm going to add over here graphically. Okay. So for this method, you must be given a graph. So I give you the graph like this. Okay, and over here 2, and this is 4. Okay, so I can evaluate the function fx. This graph represents a function, so I want to evaluate this function at 2, and the 2 here give you the output is 4 correspondingly. Okay, I will be doing more exercise and practice later, but I just want to show you 3 examples over here. Okay. It's not hard. I just look at the graph, look at the function, and you can see that. Okay. Okay. Next, I want to show you how to find the domain and range from the graph. Find domain and range from the graph. Okay. As we know, the domain is all the x value that make the function defined. So in order to find the domain and the range for the graph, they must give you the graph. Okay, they must give you the graph. I think I'm gonna just pick one of the graph here in this textbook. I just go ahead and pick one of the graph, and I will have you find the domain and range. And all the range, the domain will be on the x value, and the range will be on the y value. Okay, so I think, or maybe I can just go ahead and make up one of the function. Okay, so I think I'm gonna just go ahead and make up one of the function. Okay, something like this. I give you the function like that. Okay. And over here, I use the circle, and over here is the value here is about -3, and over here I use the dot sign, and the value here is 5. So the and the y value here corresponding to -3 will be -2, and over here also this is about negative, is +3/2. Okay. So the domain, you see that every point on the x-axis, if you draw the line, it gives you a point on the graph. For example, if I pick a point on the x-axis here, I draw the line, I give you can get a point here. If I start from the point here, I draw another line, I can get a point here, and so on. So any point here, I can get a point. Any point on the x-axis, I can get a point on the graph, right? Okay. Any point here, I can get a point. Any point on the x-axis, I can get another point on the graph. However, at -3, if I draw the line, right? It gives you the circle. It means that at -3, we cannot get a point on the graph. So the domain will start from -3, but cannot be included -3 because at -3 we cannot get a point on the graph. Okay. However, at 5, I can get a point on the graph because I have a dot sign here. So the domain will be -3 to 5, included 5. So every point between -3 and 5, not included -3, will be the domain of this function. Okay, does it make sense to you? For the range, the same thing. Every point on the y-axis, I can have a point on the graph. Let's see, every point here, I can get a point on the graph. Every point here, I can get a point. Every point here, I can get a point. However, at -2, I cannot get a point on the graph, right? Because it's a circle here. It's the empty circle. It means there's no graph over here. It's nothing in here. So the range will be from -2, not included, right? To what? To the maximum point of this. So that over here negative. I think over here is 2. Okay. So, -2 to 2 included. Okay. So the range go from the lowest point of the graph to the highest point of the graph. We'll be talking about a minimum point of the graph and a maximum point of the graph later. Okay, but right now you just take it for granted that the range always starts from the lowest point of the graph to the highest point of the graph. Okay. So remark, use parentheses for the end that have circle. So you see over here the end of this graph here have circle, so I use parentheses. I want to write it so that you can remember. Okay, this is very important because I see a lot of students use bracket for the circle, for the empty circle, which is wrong. Okay. Next, I want to do some problem in the textbook. Let me pick some of the problem here and we can practice together. I want to do the problem that asks us to find the domain. So let me see. Evaluation is easy. Evaluation is you just go ahead and plug into the function. but for the domain sometimes it's very hard, depend on the function you have. Let me see, we have any of them. They don't have any problem here, so I think I'm gonna just go ahead and pick something. Okay. I want to do, okay. Okay. So I want to do problem 20, page 45 here. They give you the function, they give you the table, and we don't know if this table is a function or not. Okay, so we need to verify if it's a function, and we need to check if it is a function or not. So on part A, they ask you, how do we know this table represents a function? If we look at the input, we have 3.2, 3.5, 2, 3.059, 0.59. So we have different output, and we also have we have different input. I'm sorry. Then we have the output over here kind of the same. We have 60 and 60. So two input give you the same output. Two input give you the same output. So it's still a function. If you have one input give you two different output, then it's not a function. Okay, but two different output give you the same input, so it's still a function. Okay, remember that. Okay, so part A is it represents a function. So part A, they want to identify the input and the output. So input is this, and you can write it using the set notation. So the input or the domain will be 3.2, 3.5, okay, so to 1, 2, and 0.59. So I use the set notation to write the domain or the input or the element of input, the set of input, and the range will be 60, 44, 74, 86, and 60. That's part B. Okay. Part C, they want to evaluate the function at h at 1. So you look at 1, and I have the output correspondingly is 74. So h at 1 give you 74. Okay. Find the value of the function t when ht equals 60. So ht, remember fx, y equal to fx, and y is the output. It means fx is the output. So ht will be the output, and the output is 60. We have two different input, so the value of t will be input in this case. So the value of t will be 3.2 and 0.59. Okay, 2.2 and 0.59. Okay, and for part E, they want you to state the domain and the range. So I already did that for you. Okay, so I think I can stop the lecture now, because I think I almost cover most of the important part of function. In the next lecture, I will cover how to how to know if the graph is a function, how to know if it give you the function. We know right away if we give you fx equals something, expression, we know right away it's a function. Okay, and that thing is called we using something called vertical line test. I will cover that, and I also cover increasing and decreasing interval of the function. Okay, so if you like the video, and if you think that this video is helpful, and or if you want me to solve some sort of problem in the textbook, or if you have any question, don't hesitate. Give me a comment or let me know under the YouTube video. Then I see that if I have time, and I'm sure that I have time, and I'll see that if I can help you with that. Okay, thank you so much, and I'll see you next time.